Okay. So to start the deep learning tool, um, one of the one of them is the segmentation wizard. Another is from the top menu. You have deep learning tool. Deep learning tool is also deep learning is tool is like a full um a full function suite. It can do everything you need to do with deep learning, but it's not very friendly for beginners. That's why we have a wizard. We call it a segmentation wizard here. So this is the tool we recommend for beginners to use. So we right click the segmentation wizard. This one normally you don't need to do anything for this. This means if you have multiple images for the same sample, it's not for multiple data set for different samples. It's not to train the model with different samples. This is a very special case for one sample. You have multiple scans. In that case, we can use the multimodality, which is here. But we're not going to use this now. We just keep it the on a single image, the simple input. So we just do continue. Now we are in the wizard. The purpose of the wizard is to create a model. When I say model, it means a neural network, a deep learning model, which can be trained in the wizard. So to train the deep learning model, we have to prepare some training data, which is now the frames. I can add a frame here. So I have a new frame one here. And you have to specify how many classes you want for this frame, which is how many faces you want to segment in the image. In my case, it's 3. So I add one class. So the first class, I can say this is the high intensity phase. This is a medium intensity phase. And this is the lower. So for the high one, I'm going to label the high phase that I want to segment. I use the brush. When we use the brush, it's a 2D brush. It just paint on the current frame. Um, we have 3 different mode. The full mode is wherever you paint, you paint all the pixels. So I use control to paint. I use the shift key and my mouse. So shift to remove, control to add. But I'm going to use the local auto. The local auto, you have two like two faces to choose. You can paint lower intensities or you can paint upper intensities. So the auto will always divide my brush, the area under my brush to 2 regions, 2 sub-regions. One is upper, one is lower. So when I say upper, it will paint, you see only the upper intensity. So I can paint pretty quick for my upper intensity, which is the high intensity phase which I want. But because of noise, you see also we have some noise labeled here. If you don't see it clearly, I can change. So you can remove all this. Now I'm changing to shift key. I can remove everything which is not here, not which not belong to my face. Uh, okay, I can do a little bit cleanup. I can also use the smooth tool, which is here. I can also smooth my labeling here. So now I'm done the high intensity. Now I'm going to work on the medium intensity. I change to the second class. Then I'm going to again use the upper. You see, because the noise is not fully well picked or labeled, but I can let me try this first, and I'm going to use the smooth feature to make it better. So what I'm doing is the manual segmentation. I'm going to use this as the training data, which is the ground truth. So I'm painting the ground truth, and I'm going to use this to train my deep learning model. Another way is you filter the image, then you paint the the ground truth, like what I'm doing now. You paint the ground truth on the filtered images, but you train the model with the original, the raw data. That's another way to do this. I have painted my second phase, the medium intensity. I want to make it smooth, so I use the smooth button. You see here, it's smoother now. I can do it further. This is a kernel. For a higher kernel, a larger kernel, I can make it more smooth. Now you see the face is is very well with filled. For this part, it's not filled because they have pretty big internal like structures like this. It depends on if we want label them. Um, it we need to judge. It's not obvious if we want label this as medium phase or as lower phase. If we think this should be labeled as medium phase, then we should do it um, now, because this is the training data we give to the model. So what do we do here? The model will learn from this, and then the model will reproduce this. Sometimes we will need to go through a few slices to make sure if it's the structure that we want. So when I go through the other slices, I think this is kind of internal structure. It's not like opening of another phase and the lower phase. So I label this as I label this as the medium. This one same. So it's just a demo. In your real data, in your real project, you have to be careful what do you want to label here, because what do you give here is what do you get by the model later. So if we have done with the phase, I will do the third phase. The third phase will be much easier because I can add all unlabeled pixels or voxels to this class. So I just right click and then label everything here. So for deep learning, at this moment, with this version of Dragonfly, we have to label all pixels, in the frame for deep learning. But for last week, we demoed the machine learning, which is a traditional way for not deep learning based method. It's a like random forest. It's machine learning method. In that case, you don't need a full segmentation for training. You can do sparse labeling, like you have some labeled here, some labeled here, some labeled here. You can train the random forest. But this is different. For deep learning, you have to label them fully of the frame. When this is done, we can use this as the training data for the model. Then we go to the model tab. You can add a model. We have different architectures for deep learning. The most popular is UNet. So you can always start with UNet, or you can also use the attention unit, which I use very often now. It's a enhanced version of UNet, and I found it has good performance. Most of the time, it has a good performance, or even better than the standard UNet. But we're going to start with the standard UNet. Um, so you can choose the input dimension 2D or 2.5D. It simply means the input is only one image, like the current slice, which I pinned, or it takes multiple slices. For CT data, because it always have more information in the multiple slices, you get more information from the previous slice or next slice or even next two slices. So it will help the model. It will help the program to identify the the faces for every pixel, yeah, which face should belong to. It's, it's like human. Sometimes we have to check the other slices to make sure a structure is part of the face or another face. Um, so we use this 2.5D. I keep this as default. So the three slices, and this is the level, the unit depth level. So for higher level, the model will be more complex, and so it's you will need more data to train it, but it can be capable of doing um more difficult tasks. So if you think your image segmentation is more difficult to do, you need a higher level of the depth. I always start with number five, so level five, and this the second is the filter count, which means how many filters you use for extracting the features. Um, I always use the default one because with more features you need it's more slow. I mean it need more time. It's slower to train, and it need more training data. So I often use the default one. Um, so now I'm generating the new model. The new model is ready now. So you see it's here. Um, now we can train the model, but before we train it, we can double check the training parameters. We right click and we go to training parameters. There are a few things we have to pay attention to, like the patch size. Patch size, let me close this first. Patch size means how big the the program will cut the image to small patches, because I'm using now the brush to indicate the size of the patch, because I have the size for my brush. So if I use 64, this means my brush now is 64 by 64. It's just for you to have some idea how big the 64 patch is. So we need to see the features very well in each patch. So I think 64 is a good one. If, for example, if we use a very small patch, if we use this size for patch, for most of the patches, you see only one face. You see only either medium face or the lower face. For very few patches, you see two face or three faces, and that's not good for deep learning. So we use a larger face, large part patch like this. So for most of the patches we have at least two classes. So that's how we choose the patch size, depending on the image features. So 64, the stride ratio is when you move one patch to another, how much you move. So 0.2 means you move only 20% of of the patch size. So it will have like 80% overlap. Um, we use a lower ratio to get more patches. So in the beginning, we don't have so many patches for training, because you see I labeled only one frame. We don't have that big image for training. So I use a lower ratio so I can get more patches. So epoch number default is 100, which I just want to train the model 100 times and see how it goes. And this is the loss function. We normally use the first one or the dice, the most two popular loss functions. So the first one is cross entropy, and the second is the dice coefficient as a loss function. So the loss function is a measurement between the ground truth and the prediction, because the objective of the model is to achieve a prediction as close as possible to the ground truth. So the loss function, a lower loss function, meaning the model is it is producing good prediction, and the model have a good performance. So the training will try to reduce the loss function. It's quite straightforward. So optimization algorithm, I always use the default, even we have many options here. So for early stopping and the reduced learning rate, I don't use them often. We can talk about this later. For data augmentation, it's just to produce more training patches or training data um, to improve the training performance, because we 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 need more data for training, but we don't have that many. You see, we have only one frame, so the program can produce some like fake data, fake images by transforming them, because we can transform the labeling, the ground truth at the same time. So we don't need to reproduce, we don't recreate the ground truth again. The program will calculate everything and use the deformed image as new image for training. So that will help to generalize the model a lot. So the model will not have the overfitting issue. So when I have less training data, I use higher augmentation, like higher ratio for augmentation, which is 20 times the maximum. So now I can train. I set up my training data. I set up my model training parameters. Before I train, I just create another frame, but this frame is not for training, it's for monitoring. So for each frame, you have an option here, a drop down menu for what this frame is used for. So it could be, the frame could be used for training or validation, or mixed. Mixed is for both training and validation. Um, Also, we can use that for monitoring. For monitoring, we'll see when we do the training now. So I hit the train button. When we do the training, we can see first the information we have set up, how we set up the models, which model we used, we created, what parameters we set for training, and what parameters we set for data augmentation, and also how many data has been labeled, or how many patches have been produced by the program for training. And below the left is the loss function, how it goes with the training epochs. Now we have done 2 epochs already. Now it's the third one. And the right side is the prediction of the model on that frame, the monitoring frame. So this is a visual feedback for us. We know how the model is doing. At this moment, the model doesn't do anything because every pixel has been labeled as a low intensity phase. So we're waiting for more epochs to see if the model can be trained to find more phases properly. So we just give it a few minutes, maybe 2 minutes to see if it's getting better. Well, it's pretty slow. It's slower than I expected. I expected to have something like this in 10 epochs. Now it has taken 25 epochs. We still get a little bit, well, get something. It's getting there. You see, distinguished two phases, the median and the low phase. It has not found higher intensity yet. So it's keep working on that. The idea is to train the model to get the best prediction, and you can verify by loss function. You should go much lower than this. Um, well, if you not if you don't get a good result from the model, there's many things you want to try. You want to give a bit more training data, or you want to create a new network, new model. You want to change your model, for example, from change from UNet to attention unit or other network. Or you can change the training parameters. In fact, there are many different options to try, and then we have no answer uh, for sure which one is the best to use. Um, all this depends on the experiences and your judge about the data. Uh, so I would encourage you to try it and to find the but use your with your own data to find the issue you have with the method. Let me know if you have difficulty to train your own data for segmentation, and that because there's um, some concerns we have to take in the beginning. For example, the intensity calibration, how we pre-process the image, how we choose the best image plane to use for deep learning. There's many issues to consider. Not everyone is critical for every case, but we have to learn all of them to get the experience. Um, So you see, we haven't got the best result here. We haven't got to the higher intensity phase so far. So I will stop now because I don't have that much time to continue. If I if I do want to continue, I would like to see, I will add one more phase because one more frame because now I have only one frame for training, and particularly the high in intensity phase is not that big in terms of the number of pixels or the areas. It doesn't show up in all the many patches. So I would add more frames. That's one thing I want to do. And another is if I'm not happy with this network, I can delete it or I can uncheck it and then just create a new one, maybe with some other settings, and try to train the new model, and I can compare different models. Even um, we could have as many model as we want, and we can compare three models at one time. So, okay, for example, here, this is my ground truth lower section. It's my prediction of the model. Obviously, it's not a good prediction. So model doesn't work well. That's why we have to keep training um, and compare different models. If I have two model, I will have two sections in the lower part, and I can compare different models. So that's it for today. It's a quick demo of deep learning. For sure, we'll use this more often in the future, and we'll demo this with more sessions or more data. So does anyone has any question before we close? All right. So I hope everyone have a good night and see you next week.